particular video, we'll be covering the topic of probabilities. Okay, we are doing this mathematics application and integration. Okay, IB Maths HL level. Right. So the page that we're starting off with will be 596. Okay, finding probabilities. Okay, the bottom half. Okay. Right. So for this question, example 9, you need your GDC. Right. Okay. The question goes like this. Okay. If X follows the normal distribution, okay, with mean 10 and variance 4. Okay. Take note that the second parameter is actually variance, not standard deviation. Okay. You're supposed to find, okay, let's do it. Okay. Probability X is more than 9 but less than 12. Okay. So to do that, you need to take out your calculator, your GTC, okay, turn it on. Okay. Alright, so you're supposed to calculate that particular probability. Okay, so we have learned before, to find this, we need to find probability X is less than 12. Okay. Subtract probability X is less than 9. Okay. Alright, so we've done this in Poisson and nominal probability distribution. Okay. So let's try it out. First, what you need to do is go to distribution, which is second bars. Okay, and then you find under normal CDF, okay, which is number 2. Okay, the lower one, please do not key in anything. Okay, right. So the lower is set at there. Okay, the upper is the one that you will be setting. Okay, so if you want 12, the upper will be 12. So you want from 12 backwards. Okay, the mu is the mean. Right? So in this case, our mean is 10. So key in 10. Okay. Standard deviation, please don't be tricked, is not 4. It is actually, this is variance, so it's standard deviation squared. So the standard deviation is actually 2. So key in 2, not 4. Okay. Paste that into your main page. You will get 0.841. Okay. This is 0.8413, for example. Okay, and then do likewise for the normal distribution for this one. Okay, X is less than 9. Okay, so for X is less than 9, it will be 0.3085. Okay. Okay, so what I need you to do, you're supposed to take this, subtract this, right? Okay, what you're supposed to do is you're supposed to go up, okay, highlight that answer 0.8413, okay, and press enter. They will copy and paste it to the next line. Okay, go up. Okay, sorry. Before that, press minus because you're going to subtract. Go up. Find back this 0.3085 here. Okay. And then press enter again. They will copy paste to the same line. Okay. Now I press enter. This will give the exact value of these two probabilities when we subtract them. Okay. So it's 0.5328. So 532. Okay. And that's how the book got as 0.533. Okay. So I'll erase and do the next one. Okay. Next one is probability X is less than 30. Okay, so similar to just now, we just use the calculator, probably normal CDF, okay, and then calculate that. Okay, so this will be 0.933. Okay, so this is rather straightforward. Right, now we come to C. C is probability X is more than 7. Okay, as we know, our calculator is not able to calculate X more than. Okay, so what you can do is you can take 1 minus probability X less than 7. Okay, but what the book wants to teach you here is not that technique. Okay, what the book wants to teach you here is try to visualize the normal distribution curve or the probability density function. Okay, for the normal distribution, this is the probability density function. Okay, the mean will be in the center. Okay, the graph is symmetrical to the mean. Okay, symmetrical to the mean. Okay, so that means this is 10. Okay. Where is 13? It will be 3 steps. Let's say here, this is 13. Okay. When we say that the probability of x less than 13 is 0.933, that means the area here is 0.933. Okay. Now where is 7? 7 is 3 steps behind the 10. Can you see the symmetry? If this is 3 steps ahead, the area is 0.933. This particular area is 0.933. Okay. And then I change this, I don't want here, I want here. It's actually a flip version. Okay, from here, right? You flip it, okay, you will get this part. Okay, so this particular area here, okay, is the same as if you were to go from 13 backwards. Okay, so 13 backwards is the same as 7 forward because of the symmetry that it has. Okay, having the mean 10 in the center. Okay, so what they want to teach you is probability x more than 7 is actually the same as 0.933, the same as probability x is less than 13. Okay, so they just want to teach you a shortcut. Okay, instead of calculating it. Okay, right. So we'll look at example 10 after this. We are back. Okay, let's look at example 10 on page 597. Okay, let's read the question together. The lengths of trout in a fish farm are normally distributed with a mean of 39 and a standard deviation of 6.1 cm. Okay, find the probability that a trout caught in the fish farm is less than 35 cm long. Okay, so let's do that. Okay, first thing first, we need to call the normal distribution. So we let L, okay, be the length of a randomly selected trout. Okay, so L, they say it follows the normal distribution. The mean is 39, but the variance is not 6.1. 6.1 is the standard deviation, so it's 6.1 squared. Right. Okay, so they want the probability that L or A, they want the probability that L is less than 35. So using the GDC like just now, you need the normal CDF, okay, and you calculate it to be 0.256. Okay, so try it out in your calculator. I'm sure how we get there. Okay, now for part B. Cliff catches 5 trout in an afternoon. Okay, so he caught 5 trouts. Okay, find the probability that at least 2 of the trout are more than 35 cm long. State any assumptions you make. Okay, so first thing first, there's 5 trout. Okay, and then we want to find whether what's the probability that 2 of them will be a certain feature and stuff like that. So 2, 5, there's 5 now. So that will tell you that there's 5 trials, there's a fixed number of trials. Okay, so this is actually a binomial probability distribution. Okay, so since they say the person is Cliff, right? Okay, so they let C, okay, represent, okay, the length, sorry, the event that 5 of the fish are more than 35 cm. Okay, alright. So C follows binomial. Okay, and the fixed trials is 5, but the probability, right? Okay, they want more than 35 cm long. Previously we calculated this one is less than 35. So the probability will be 1 minus this particular value. So it's 0.744. Okay, so what must you assume? You assume, okay, that the length of each fish caught is independent. Okay, this is the typical binomial assumption. Okay, that each trial is independent of the other. Okay, so you want to find that at least two of the trials are more than 25. So you are calculating probability C is more than 2. Okay, sorry, at least 2. So it's more than or equals to. Okay, so to calculate this using your GDC, you have to do 1 minus probability C is less than 1. Okay, because you want 2 to be included, so you have to be less than or equals to 1. Okay, and you will get it to be 0.983. Right? Okay, so we are done. We are going to do part C, but I'll erase the boxes. Okay, for part C, okay, we're supposed to find the probability that a trout caught is longer than 42 cm given that it is longer than 40 cm. Okay, so we are supposed to calculate this conditional probability that L is more than 42 given that L is more than 40. Okay, so we know by conditional probability the numerator is actually probability L more than 42 intersect with L more than 40. So number line will tell us that it is actually probability L more than 42. Okay, because we want the intersection, right? So more than 40, more than 42, we choose more than 42 as the intersection. Okay, and the bottom part, the center space will now be reduced to probability L is more than 40. Okay, so using your GDC, this is all more than, so you have to do 1 minus accordingly. Okay, you will get it to be 0.716. Okay, using your GDC. Okay. Okay, now we attempt part D. Okay, determine if the events L more than 42 and L more than 40 are independent. Okay, so recall that for an event to be independent, okay, there's a few things we can use. Okay, so one of the things that we can use is if probability A given B. Okay, if A and B are independent, that means probability that A happened given that B has happened will be equals to probability A. That means B will not have any effect on A. Okay, B will not change the probability of A in any way. Okay, so probability of A given B must be equals to probability of A. Okay, so that means probability of L more than 42 given that L is more than 40, okay, has got to be equals to probability L more than 42. Okay, this is the A, this is the B, this is the A. Okay, so the thing is when we calculate this left part, it is actually probability L more than 42 given L is more than 40 is actually 0.716. But probability L is more than 40, okay, is given as 0.311. Okay, since they are not the same, okay, we cannot say that they are independent. So since these two properties are not the same, okay, given in your book, the events are not independent. Right? Okay, so that's example 10. Okay, we will now move on to example 11 and 12. Okay, since this topic is quite huge, okay, I might be putting this in another video. Okay, so remember, teachers, we don't just teach professionally, we teach professionally.